friends, it's so good to see you all again. So welcome to 5G System Architect Training. This is Gaurav Goyal. First of all, thanks a lot for joining this training. Instead of spending time here and there, you are here. This proves you are serious about yourself. This shows career growth means a lot to you. So again, I really appreciate from core of my heart for giving me your precious time. I will try my best to make every second of you worth through this session. Again, this is me. My name is Gaurav Goyal. I have been in telecom industry for over 17 years, mostly in wireless industry. I have worked in telecom in one capacity or another. I have worked for all the largest telecom service provider in US. Like AT&T, Verizon, T-Mobile, etc., and also with major vendors like Nokia, Ericsson, Huawei, etc. And before coming to US, I have worked in various countries like India, Nigeria, Finland, UK, etc. So much of time has been spent in wireless networks only. And I have begun my career with 2G and now working with 5G for at least last 4 or 5 years. And at this moment, my focus is on 5G, Python, and ORAN. Okay, friends. So this is about me. And for more details about me, you can check my LinkedIn profile. And these are all my experience. So these are all my ID cards. And before jumping to topic, I want to say one thing, that your involvement in the class is critical for you to benefit most from this session. I request you, if it is not absolute necessity, then please close your Outlook, social media, Facebook, WhatsApp, etc. if possible. Because it's a proven fact that there's no such thing in the world called multitasking. Even a genius can't do two things at the same time. So it's my kind appeal to everybody. Please close all kind of social media or any kind of distraction. Moreover, there will be quiz and only person who is attentive can answer those questions. Also, please stay till the end because I will offer lots of bonuses and offers on my complete 5G course. And if possible, please hold your question till the end. I will take your question in the end because as sometimes answer to your question is available in the very next slide. And moreover, it affects the continuity. So please ask your question at the end of the session. So are you with me? So if yes, then please write yes in the chat box and then we can continue our training. Okay, thank you. For the 5G architecture, let's talk about agenda. So there are many new features in 5G, but I feel different core architecture is one of the most important feature as compared to LTE. It has many new features like separate user plane, control plane function, service-based architecture, network functions, NFV, SDN, network slicing. So 5G core has many new aspects as compared to LTE. So in this webinar, we will analyze some of those aspects of 5G core architecture. To understand 5G architecture, first of all, we have to understand its building blocks. What are the building blocks in terms of network capabilities in 5G? First of all, we have extremely large bandwidth. You can see here that we have, we have extremely large bandwidth, right? And we know that in case of 5G, the target downlink data rate is around 20 Gbps, right? Such a large data rate can be achieved because we have a lot more spectrum deployed in 5G. As you know that according to Shannon law, that C capacity is equal to bandwidth log 1 plus sin R, right? So if bandwidth is high, our capacity, our throughput, everything will be high. So large bandwidth is very much required if you want to achieve high downlink or uplink data rates. Then we have mixed spectrum. We have spectrum for low band, mid band, high band, etc. Right? If you know that we have FR1, which is between 400 megahertz which is between 400 megahertz to 7 gigahertz, right? And we have FR2, which is between 24.2 gigahertz to 52.6 gigahertz. So in case of high band, or more specifically, you can say millimeter waves, those channel bandwidths are a lot larger. It can go up to 400 megahertz. And you know that very well that data rates I can achieve on air interface is directly proportional to the size of the channel, right? So in case of LTE, maximum bandwidth is 20 megahertz, and with the help of carrier aggregation, it can go up to 100 megahertz. Now we are talking about 400 megahertz channel bandwidth, so that can provide a lot larger, higher data rates, right? Other building block is our beamforming and MIMO. So beamforming is successful when we have large number of antenna elements. As we know that in 5G, we can use millimeter spectrum as well. And millimeter waves means very small wavelength, or you can say very high frequency. In wireless networking or in wireless in general, the antenna size is function of wavelength. The smaller the wavelength, the smaller the antenna. So I have done this calculation. So at 4.5 gigahertz, you can see that our wavelength is around 0.067 meter. At 28 gigahertz, our wavelength is around 0.01 meter. At 60 gigahertz, our wavelength is around 0.05 meter. So you can see that antenna size is becoming smaller and smaller as we move from 4.5 gigahertz to 60 gigahertz, right? Initially it was 0.067 meter, but now it's reduced to 0.0005 meter, right? So in macro cellular type, at this moment, we are used to seeing those poles with bigger, tall, and antennas on top, right? 6'8", 6 foot, 8 foot, tall, high, or something, right? So when we get into millimeter wave, radio, because the wavelength is only a few millimeters, those antenna sizes becomes very small. So that means we can put together a lots of antenna in a particular radome or box, which is called antenna array. The more the antennas, the more we can make use of multiple antenna techniques such as beamforming, MIMO, or you can say massive MIMO, multiple input, multiple output. So with beamforming, our SINA drastically increases, which in turn helps us getting more data rate. Why? Because according to Shannon law, capacity is equal to bandwidth log 1 plus SINA. So if our SINA increases, our capacity will also increase, right? Then we have this flexible frame structure, right? So in case of LTE, as you know that our subcarrier spacing is fixed, that is 15 kilohertz, right? But it is not fixed in case of 5G. In case of 5G, we have various kinds of subcarrier spacing, like we can have 15 kilohertz, we can have 30 kilohertz, we can have 60 kilohertz, we can have 120 kilohertz, and we can have 240 kilohertz, right? And because of that, our transmission time interval also reduces, because transmission time interval is inversely proportional to sub-carrier spacing. So here our TTI or transmission time interval is 1 millisecond. Here we have 0.5 millisecond. Here we have 0.25 millisecond, and so on, right? It will reduce by half as we move from one sub-carrier spacing to other. So slot timing is inversely proportional to the sub-carrier spacing. So due to variable sub-carrier spacing, the slot timing is variable in 5G. At high level, you can say slot timing is equal to TTI, time transmission interval. In case of 5G, slot timing can be as high as millisecond or as low as quarter millisecond. We thought LT is fast. If in LT we can make 1000 decisions per second, here we can make maybe 8000 decisions per second in 5G, right? It's crazy fast. This is how quickly we can send things over the air. If you remember that in case of 5G, we have three main cases. One is MMTC, which is massive machine type communication. Then we have EMBB, enhanced mobile broadband. And then we have URLLC, ultra reliable low latency communication. And this has strict requirements of latency. So that quarter millisecond slot timing, which is the time transmission interval, is one of the capabilities that enable for low latency communication. The smaller the slot timing, the more frequently we are sending data over the air, and hence our latency will be reduced. Then we have this split architecture. You can see here. So you can see the two new terms. One is DU, which is called distributed unit, and one is CU, which is called the centralized unit. So we will discuss in detail in next few slides, but at high level. So today's architecture of 5G, we have what is called baseband unit in case of 5G. In case of LTE also, so where you will use one thing called baseband, and it is also called CU, right? And baseband is our digital processing unit, right? So it connects via fiber typically to a radio head or radio unit. So we have centralized BBU in LTE that serves various sectors. But what we are doing in 5G is that we are going to able to split that BBU or CU into something called centralized unit and DU, which is distributed unit. And this distributed unit will be near to the site. But we'll discuss DU and CU in quite detail in next few slides. But right now, just remember that in 5G, BBU is divided into two parts. One part is DU and one part is CU. And then the other capability of 5G is the support for edge computing. It is also called MEC, which is multi-access edge computing. Right? So the main purpose of edge computing is to move processing near to the network edge. One of the advantages of that is that we can reduce the overall latency. Earlier, data has to first go through the core before being processed and then delivered to the user. But in case of MEC, data will be processed at the gNodeB rather than taken to the centralized cloud core network. Therefore, it will save lots of transition time interval and TTI will be reduced. Then we have this network slicing. So basically, network slicing provides end-to-end logical network. Those logical networks are completely isolated from each other and work independently. As I said, we have many cases in 5G like EMBB, URLLC, and MMTC. But if network slicing is not there, we need different infrastructure for each of these cases. So network slicing is a method of creating multiple unique logical and virtualized network over a common multi-domain infrastructure. The main purpose is to provide flexibility and scalability. Then we have this 5G core. Right? So on the 5G core itself, the 5G core will be virtualized, running on cloud platform. Again, flexibility and scalability. So here we are going to do virtualization in a big way in core. In LTE and all previous technologies, we have bought vendor-specific hardware and software bundled all together. For example, we have MME, right? We have SGW. So if I bought one box for MME, right, then this box will only work as an MME. We can't use this box as SGW or PGW or any other thing, right? So this box will always work as MME. So these things are always vendor specific. It's a proprietary hardware and there's software on top of that. But with the help of this network function virtualization, we are going towards in the future is the virtualized software right on the top of operator hardware. The idea here is that as an operator, instead of buying the hardware from vendor, we can provide our own hardware. You will notice that one thing here, that there is F in the end of each node, right? There is F at the end of each node. F stands for function. So this would be like access and mobility function. And it is depend on what is called, if you heard this term, called COTS, right? Commercial off the shelf. So COTS is the term given to the hardware that is delivered to the customer with no pre-installed software. Our own server hardware from companies like HP or Dell, right? Or any of those companies that provide enterprise service, right? So, well, we already have great hardware. So why do I need to buy hardware from a vendor, right? Like an Ericsson, Samsung, Nokia, or whoever, right? So why can't I just get the software and put it on the hardware and then virtualize it? So that is coming, and that is coming very fast in the 5G core, right? So these are the few main components of 5G. One, as we discussed, is the large bandwidth, right? Then our support for, so first thing is we discuss is large bandwidth. Then we have support for various kinds of bands. It can be low band, it can be mid band, and it can be high band. Then we have beamforming and MIMO. After that, we have flexible frame structure. In addition to that, we have split architecture in case of 5G. One is, and it is divided into two parts. One is DU and one is CU. Then we have this multi-access edge computing, and then our 5G is completely virtualized because we want to provide it high flexibility and scalability. The main purpose of providing 5G is to give lots of flexibility and scalability. Right? So this is what I was talking about earlier. So you can see that at 4.5 gigahertz, our wavelength is 0.067 meter, and our antenna size is 1.3 meter, such a big antenna. But as we move towards 28 gigahertz, our wavelength is reduced to 0.01 meter and our antenna size become 0.2 meter, right? And at 60 gigahertz, our wavelength is 0.005 meter and our antenna size is reduced to 0.1 millimeter, right? And as I said that beam forming is successful only if we have large number of antennas, right? So here it may not be possible at 4.5 gigahertz, but as we move towards millimeter wave, we have large number of antennas in a small radome. That's why beam forming is possible, right? Yeah, this is what I was talking about, that if one hardware, so this box is used for PGW, right? So this box will not be used as a MME or SGW, right? So this is a 4G is very monolithic. It can't be used for any other purpose. But in case of 5G, we have function. So any box can be used as anything according to the requirement, right? So these are PGW. So this box will always use as HLR. This box will be used as MME. This box will be used as OCS and so on, right? Like first part is, you can say, is the UE, right? Then we have this EUTRA. Then we have this EUTRAN. Then we have this EPC. Then we have VoLTE, right? And then we have this PDM, right? PDM. And in 5G, this is our 5G system. And here we have first part is 5G UE. Second part is air interface is NR. Then we have this thing, which is third part, which is 5G RAN, or you can say NG RAN, right? Then we have this fourth part is 5G core. And then we have this VoNR, voice over NR, right? So we have seen some of the changes from 4G to 5G. We know that we have a new air interface, the new radio interface. We know that we will have a new 5G NodeB that supports the NR air interface. All right. So in LTE, we have an evolved packet core, what was based on the vendor specific hardware and software. In 5G, we are going to have a virtualized core, and it is to be composed of network functions. They are going to replace those previous solutions, right? All right. So earlier we have, maybe here we have MME, SGW, PGW. So these are replaced by function. I will discuss in detail, like AMF, SMF, right? So of course, 5G will support IMS, public switch telephone network, external data networks. So we are going to a cloud type of architecture. Then we have this CU and DU type of architecture. Right? So let's remind ourselves couple of things about LT-RAN architecture. I remember when I was teaching LTE. So you know that there is one antenna here. There is one radio. And there is one BBU. All these things on the site. And BBU is connected, you can say, to the core with the help of this backhaul, right? And between radio and antenna, there may be a coax cable, and here there can be a pipe, right? So there is an antenna, radio, and BBU to connect backhaul to the core, and we have fiber connection between BBU and radio, and coax between radio and LT. We brag all the time that no radio network controller like 3G, and all the functions moved to the site, and everybody was happy, right? But then comes the LTE advanced. Right? So here, same thing. We have one antenna. We have one antenna on the top of the tower. Then we have a radio. Right? And then radio is connected to a BBU, which is not at the site. This is also called CU, centralized unit. And then this is connected to the core. And there may be a fiber between this, and there may be a coax. Right? And this fiber can be 15 to 20 kilometers. And because with the help of this BBU, we can have more towers, more radio, and it can connect it to this BBU. We can have another tower, antennas, and radios, and that is also can be connected to BBU. So we will have tighter coordination between cell sites, right? So we still have antenna and radio, and we have coax connected, but 3GPP had decided for some sites that baseband unit at one common place, so it can coordinate with other sites, and we can pool hardware at a centralized location. So I can have baseband unit at a site or some common location where we can coordinate. But neither of two solutions discussed were perfect. For example, here maximum distance can be 15 to 20 kilometer fiber possible, right? So for some sites, this scenario may not be possible. And for those sites, then I do not get coordination and the pool hardware. Then comes the third scenario, which is 5G. What happens in case of 5G? So we have one antenna, or you can say one tower. You have tower, on the top of tower, there can be RRH or radio, whatever you say. And then that radio or RRH is connected to the DU, which is distributed unit. And this distributed unit is connected to the central unit. And this is connected to your core. Sometimes nowadays we call it as a backhaul. This is called mid-haul. And this is also called front haul. Okay, and here we can pool the number of sites, right? And at this moment, there is no distance limit. Right? So in 5G, we have some better things possible. So BBU is divided into two parts. One is DU and other one is CU. I have benefit of coordinate sites and pooling of hardware. I have Ethernet interface between CU and DU. And here I have fiber, radio, and the coax. You can see here. So it makes sense to have some of the functions of BBU at a site, and it makes sense to have some of the functions at centralized unit. So this is how they figured it out. So baseband unit is divided into two parts. One is DU and one is CU, and is no distance limit. One point to note here is that right now I am showing that DU is connected to one site, but DU can also be connected to the pool of sites as well, right? So there can be many kinds of permutation combination or many kinds of combination are possible in case of 5G. It is not fixed at all. So this is what I was talking about. So in earlier days, in case of LTE, we have RU. RU is connected to BBU, right? And all these things are on the site. You can say that on the site. Right? After that, in case of 4G advanced, there comes that RU and antennas are on the sites, right? But the BBU, which is also called CU, is shifted to the centralized location. And you can see that all the layers are at the BBU. You can say physical layer, MAC layer, RLC layer, RRC, and the PDCP layer. And this is connected to the core. But then comes the 5G. In 5G, what happens? The BBU is divided into two parts. One is CU and other one is DU, right? So lower layers like physical layer, MAC layer, RLC layer, that are shifted near to the site, right? That are shifted near to the site. But the layers which are not time stringent, that are shifted to the centralized unit like PDCP, RRC, SDAM, right? So in order to support higher data rates and low latency needs of 5G, the access network and front haul have been revamped. The gNodeB is split into two parts. One is gNodeB centralized unit and one is gNodeB distributed unit. And both are connected to each other using Ethernet, using IP mid-haul network. Generally, gNodeB CU is virtualized and runs in the context of the virtualized edge. So this CU is all mostly virtualized. And gNodeB DU might be integrated with the radio head, but it can be also virtualized and run on the edge or the cloud, right? So DU can also be virtualized. Right. Let's talk about RAN evolution to 5G. This we have already discussed. Let's talk about migration from LTE to NSA. What is NSA? NSA is non-standalone network, right? So here you can see that first option is LTE, and we all know the nodes of LTE, right? We have UE, we have eNodeB, and eNodeB is connected to LTE EPC, or you can say 4G core, right? So here you can see that eNodeB is the master because it controls signaling as well as data signaling between EPC and the eNodeB. And here also these dotted lines are control plane, and this dark lines or green lines is the user, right? It's quite simple. So end-to-end LTE, right? But then comes NSA, which is non-standalone. So now all operators wants to get to 5G market faster and also cut some cost, right? So they requested 3GPP for this. So what happened is that 3GPP responded and came out what is called as non-standalone type of architecture to launch 5G to the earliest. So what you have here is that, okay, so 3GPP has said that you can keep your core, you can keep the LTE core. You don't have to deploy a 5G core. You have eNodeB here, and that is part of your existing radio access network. So what we can do is that we come with an architecture is that we can take a gNodeB, right? And we can co-assign it with the eNodeB. You can see here two terms. One is MN. So MN is master node, and one is SN, which is secondary node, right? So we go ahead and put an X2 interface between eNodeB and gNodeB. And we know that X2 interface is the current interface we use between the eNodeB. So let's use the same interface and let's connect the gNodeB to the eNodeB. Okay. So then what we do is we make the eNodeB, the signaling master. All right. So you can see here that there is a dotted line between eNodeB and the core. You can see here dotted line. You can see here there is a dotted line between eNodeB and the UE. But between gNodeB and the core, there is no dotted line. So dotted line means the eNodeB is the master node. So any node which controls control plane functioning, that node is called the master node, right? So if you notice here in the dotted lines, we have got our control plane signaling. Then we have control plane signaling between eNodeB and the MME. In case of 5G gNodeB, we have gNodeB connection with UE over the air interface. And also gNodeB is connected to the core. So what you want in 5G? We want all the benefits of 5G air interface, things like flexible air interface, right? And greater speeds and better latency, all that. So what we all do is we'll use the control panel connection between the 5G and the core and 5G and the UE. So now the data can go through LTE and 5G as well, and we can increase our throughput, right? And then comes is our standalone, or you can say so. Somebody has asked that why we call it 3x. There is no like significance of 3. So you can see that generally we call option 1 as LTE standalone. Then we have option 2, which is 5G standalone. So option 3 is the NSA. That's why they are called it option 3. But in option 3 also we have various sub options. So they don't have better way to rename it. So they gave 3 names like option 3X, option 3A, and option 3, right? So that's why they have put it like this. So 3GP we had decided this name. So option 3, and this is option 3X. Okay. So then the third phase is option 2, which is LTE, which is 5G standalone. So next phase of evolution, of course, would be to bring the full-blown 5G core working with the gNodeB. And this will call as a standalone 5G. Of course, if you are existing 4G operator and you have spent years providing 4G service, it will take time to get to this, right? So now UMTS is almost disappeared. Same way, in couples of years, 4G may also be disappeared. But operators like Dish, which do not have LTE, will begin with ANA from day 1, right? So we have 3 options at this moment: option 1, option 3X, and option 2. There are various other options like option 5, option 4, option 7. We will not discuss in this class, but we'll discuss maybe in some other class. But right now, just remember that how to transient between 4G to 5G. So earlier we have 4G standalone, and then we have known as we have NSA, which is non-standalone, and then we'll eventually move to standalone 5G, right? Let me quickly check. Okay. Okay. So let's now talk about a little bit of NSA option 3X ENDC architecture, right? So you here see the term called MRDC. Right? You see here one term called MRDC. So what is MRDC? So MRDC is multi-thread dual connectivity. And you see there here one more term called ENDC. What is ENDC? So ENDC is E ultra new radio dual connectivity. Right? So that the node which is connected to EPC for signaling purpose is called the master node. You can see here that we have LT gNodeB here, and it is connected to UE. But you can see that gNodeB is connected to MME. You can see here the dotted line. It means control plane is the control by gNodeB. That's why it is called the master node. gNodeB doesn't have signaling path between gNodeB and the core, right? You can see here that there is no dot line between gNodeB and the 4G core. That's why it is called the secondary. So gNodeB has different scheduler, and gNodeB has different scheduler. Right? So that is why it is called dual connectivity. Why it is called dual connectivity? Why it is not called in carrier aggregation? Because in carrier aggregation, we have only one scheduler. But in dual connectivity, we have more than one scheduler for the same device, right? So that's why it is called dual connectivity, not the carrier aggregation. So here, gNodeB added to a mix of LT network. Here you see gNodeB communicates with the help of X2 interface with eNodeB. And that's why it's also called eNodeB gNodeB. So it is also called EN gNodeB, because to communicate with eNodeB, it has to understand 4G protocol. So this is EN gNodeB because it has to understand the 4G protocols. And gNodeB is connected to 4G EPC only for data. There is no control plane connection, right? You can see here, there may be only data radio bearer between UE and the 5G. But RRC connection will be between UE and the between the UE and the LTE, right? So there can be various radio bearers, as you know that one can be SRB 0, SRB 1, SRB 2. So these things will be only between eNodeB and the UE. So it means that if eNodeB is down, then connection will be down, right? So that's why eNodeB our master node. And gNodeB is connected to device only for DRB, data radio bearer, but LTE has SRB connection. Since eNodeB maintains clone control plane connectivity, it is called the master node. So here, main purpose of dual connectivity is to improve the data rate. From LTE, we already have wide coverage. So with the help of just adding gNodeB and by not changing the infrastructure much, we can increase the data rate. Only condition is that this UE should be LTE and 5G capable, right? But only problem with this setup is that it lacks various 5G features, like you can say that network slicing, cloud computing, NFV, SDN, etc. But that is the price we have to pay from moving from LTE to 5G. Next. Let's talk about key building blocks of the option 3x, right? So as you know that in case of 5G, our maximum bandwidth can be 20 megahertz. right? So maximum bandwidth can be 20 megahertz. And in 5G, we have mix of frequencies. We have like FR1, which is between 400 megahertz to, you can say, 7 gigahertz. Then we have FR2, which is between 24.2 gigahertz to 52.6 gigahertz. So here, our maximum bandwidth can go up to 100 megahertz. And here, our maximum bandwidth can go up to 400 megahertz, right? So first building block is there, flexible sub-carrier spacing in case of 5G. So we have support for low, mid-band, and high bands, and then we have large bandwidth. So as you know that in case of 5G, in case of LTE, our carrier aggregation can go up to 5 times, right? 5 carriers can be aggregated. So maximum bandwidth can be 100 megahertz in case of LTE. But in case of 5G, in some books, it's written that 16 carriers can be aggregated. So our maximum bandwidth can go up to 16 into 4, that is 6.4 gigahertz, right? So you can see here that from 100 megahertz to 6.4 gigahertz, what a massive rise between LTE and the 5G. Then we have this beamforming and the MIMO. So beamforming is possible when we have large number of antennas. As we know that higher the frequency, lower the antenna size. So with the help of millimeter waves, it is possible to integrate many antennas in a single box. Then we have this split gNodeB. And as I said earlier that we have various protocols. Some are very delay state regions and some are not. So as you know that in case of 5G, latency, you can say low latency is one of the key requirements that can be achieved by increasing the sub-carrier spacing. But along with sub-carrier spacing, if we are able to put protocols which are very delay stringent as much possible near to the user, then also we can reduce the latency. So these are the basic key building blocks of 3x. Okay. Let's see, somebody has pinged me on the chat. Let's see what he's saying. Yes. Okay. Thanks, Swapnil, for sharing the picture. Let's move to the next slide. (4G LTE, a paradigm shift to universal service platform). So let's talk about option 2, which is standalone in brief. So as we move from LTE to 5G, we can call it paradigm shift in terms of applications. The applications supported by 5G are far advanced as compared to the applications supported by 4G. So 4G is completely different standard and 5G is completely different standard. In 5G, we are adding new services, and to name a few, like we are adding, you can say that we are adding like massive IoT, we are adding augmented reality, virtual reality, we are adding smart cars, or you can say driverless cars, and these kind of things, right? We can have like industrial automation. We can have remote surgery, right? all these things, right? So this is our application feature. You can say the application feature, right? Then we have this technology feature, which is MEC, which is called multi access edge computing, right? So when we require low latency, we can take the advantage of MEC server. So what is multi-access edge computing? So multi-access edge computing moves the computing of traffic and services from a centralized cloud to the edge of the network. So the main purpose is that all the computing should be closer to the customer. So instead of sending all data to the core for processing, the network edge will analyze, will process, and will store the data. Collecting and processing data closer to the customer will reduce the latency. As I said earlier, that in earlier cases, data has first go to the core before being processed, and then it is delivered to the UE. But in case of MEC, multi-access edge computing, data will process at the gNodeB rather than taking to the centralized cloud core network. It will save lots of transition time interval, right? So what is the biggest benefit of MEC is that it reduces the latency, right? So you can use edge computing capabilities through any type of wired or wireless like 5G or Wi-Fi access. That's why it's the name come multi-access, right? Because we can use it with wired or wireless, right? That's where the name multi-access part of the MEC comes from. So MEC is a network architecture that brings the cloud closer to the customer. And there are many benefits. As I said, two main benefits are the latency is reduced because the distance the information must travel is less. Second, the user experience is enhanced for high bandwidth applications. And then we have this 5G core, right? So 5G relies heavily on virtualization. So virtualization play a key role in achieving flexibility and scalability requirements. It allows movement to vendor agnostic implementations. It allows efficient sharing of hardware. So at the core side, 5G is collection of network functions. It is expected to be virtualized and run on the cloud infrastructure. So in 5G, we are now formalizing services to the third party. Here, additional service of third party is simple because here we have service-based architecture, which we will discuss in details in next few slides. But 4G was very monolithic. So much changes are not possible in case of 4G. So let's talk about LTE network architecture. Before jumping to 5G, let's quickly review 4G architecture so that we can easily relate both technologies. Right? So in case of 4G, here we have term called gNodeB, which performs all the function related to RRC, radio connection, radio bearer control, radio management, all things related to radio, right? Then in the core, the first thing you see here is the MME. In addition to that, you see here one term called S1 and S1U, right? So interfaces there was S1. Just remember this S1 because in 5G, this S will going to change from S to N interface. Okay, we'll see in the next few slides. But just remember, in case of LTE, it was S, and in case of 5G, it will change into the N, right? So first node here we see here is the MME. If you remember, this MME is called Mobility Management Entity. And what are the main functions? Its main functions are like security procedures, which includes maybe you can say authentication. Number two, it may be ciphering, right? And it controls NAS signaling, non-access spectrum, non-access spectrum signaling, and then access spectrum signaling as well. And it controls, main function is that idle mode paging control. Right, so these are the main function of MME. One is idle mode UE paging control, and then it performs security procedures, and it performs authentication, ciphering, and integrity protection, right? And then we have this, what is called SGW, and which is also called serving gateway, right? And the main function of service gateway is the packet routing and forwarding, right? So SGW resides in the user plane, where it forwards and routes packets to and from the eNodeB and packet data network gateway, which is PGW. And then we have this PGW, which is packet data network gateway, right? So the PGW acts as an interface between LTE network and the other packet data networks, such as the internet or SIP-based IMS networks. So what the PGW does is that it routes packet to and from external IP networks. In short, you can say the main purpose of PGW, it allocates IP address to all UEs, right? So you can say PGW is the inter-system anchor point for each UE, right? And then we have this PCRF, which is policy and charging rules function. So it works in the real time. Focus on the word F. So it is function. So it is a software node. It is designated in real time to determine the policy rules in a network. So as a policy tool, the PCRF plays a central role in LTE. It accesses specialized functions such as like charging system in a centralized manner. For example, service providers can use PCRF to charge subscribers based on their volume of users. They can charge extra for quality of service guarantees. Service providers can limit app users while a user is roaming, and they can lower the bandwidth during the peak usage time. So in short, PCRF provides policy control and flow-based charging control decisions, right? This I already discussed that 4G is quite monolithic, and we are using proprietary hardware and coupled software in case of LTE. Let's see any questions anywhere. Okay, no questions at this moment. So guys, if you're following me, following the training, please can you write yes in the chat box so that I know that you are following the training. Okay, thank you. Let's talk about 5G. So if any of you have not looked at the 5G network architecture before, then here is the 5G architecture. The thing that stands out is that we have all new 5G next generation core, and we have a new base station called gNodeB here, right? You can see gNodeB, right? We have all new core network, and this core network is based on NFV, which is network function virtualization. Right? So we know that in the past you have various nodes in LTE, right? I don't know why the pen is not working. Just 1 second. These are technical issues sometimes happens. So my pen is not working. Just 1 second. Yeah, now it's working. Sorry for the interruption. Yeah. So as we know that in the past, you have many nodes in LTE, like you can say eNodeB. Then we have MME. Then we have SGW. Then we have what we call PGW. And then we have this PCRF. Right? So, well, we are going to now replace those dedicated hardware with the help of virtualized software solution. So we show here things like AUSF, AMF, SMF, right? And you can see here the word F in the end. So these are function. These are software nodes. As I said, There are various nodes in LTE like MME, SGW, PGW, PCRF, etc. The function in LTE still have to exist in 5G. I still need to register user. I still need to authenticate user. I still need to assign the IP address. I still need to manage the quality of service. So as we move from LTE to 5G, you will see some new nodes or new names. But most of the functions of each nodes are similar to LTE. So we have new names, but functions are not actually different. Let's see what are the nodes in 5G equivalent to nodes in LTE. And then we'll go through some of the important functions of these nodes. And there are various nodes in 5G, but we will discuss only few nodes in this session. So let's see. The first node here we are talking about is, so these are all the LTE, right? So first node is eNodeB, right? So eNodeB equivalent in 5G is gNodeB, right? And the main function of gNodeB is radio resource management. So under resource management comes many functions like radio bearer control, radio admission control, connection mobility control, etc. Also, it does dynamic allocation of resources to UE in both uplink and downlink, or you can say scheduling. So in 5G, eNodeB is replaced by gNodeB and functions are very similar. Then we have this MME, right? Which is mobility management entity. And as I said earlier, that main functions are like security procedure, which includes authentication, ciphering, NAS signaling, idle mode paging control, tracking area control, PGW, SGW selections, roaming. These functions are done by MME. So here, MME is replaced by, so actually, so the second thing is MME. So here, MME is replaced by three functions. You can see that all these three combinations, one is AUSF, which is authentication server function. Then we have this AMF, which is access and mobility management function. And third one is SMF, which is session management function. So MME is divided into three parts in case of 5G. One is AUSF, and one is AMF, and one is SMF. Okay. So the first important thing is AMF, right? So what does AMF does, which is your access and mobility management function. And what it does, AMF, it performs few main functions like one is registration management. Second one is connection management. Third one is reachability. Or you can say mobility. management. So first one is registration management. So it allows UE to register and deregister with the 5G system, because registration is a must for UE to use the 5G services. Then we have this connection management. So this is used to establish and release the control plane signaling between the UE and the AMF, that is across the N1 interface, right? So you can see here we have N1 interface between UE and the AMF, right? So we have N1 interface, okay? Then we have this reachability management. This is used to ensure that the UE is reachable. That what does it mean? It means that UE can be paged. The AMF supports reachability management by storing the location information as part of UE context. In case of mobility management, that is used to maintain the knowledge of UE location within the network. The UE is required to complete updates due to mobility. Example, if it moves out of tracking area with which it is currently registered. Also, the main function of AMF is to select the appropriate AUSF, UDM, etc., right, during the registration procedure. So AUSF allows the UE to authenticate itself with the 5G core network. It verifies that whether subscriber is genuine or not. So if he's genuine, then he is only authorized to access the network. Okay, and I have already said that this single control plane component that terminates between access network and UE with the help of this N1 interface, or you can say NAS signaling, right? And then we have this SMF, which is session management function, right? So the main function of SMF is it allocates IP address for PDU session, right? And together AMF, AUSF, and SMF is equivalent to MME in LT, right? And then we have this I don't know what's the problem right now. Then we have this SGW and PGW. So the main function of SGW, as we discussed, is the packet routing and the forwarding. The main function of PGW is to provide access to the PDNs, packet data network. So it allocates IP address to all UEs. So in case of 5G, there is no SGW or PGW. It is replaced by UPF. So you can see here that in case of LTE, it first goes to SGW, then SGWs go to PGW, and then data network. So between eNodeB and between data networks, there are two nodes. One is SGW and one is PGW. But in case of LTE, you can see that gNodeB and data networks, and there is only one node, which is UPF, right? Which is user plane function, right? So there is only one node between gNodeB and the external data network. So this I was discussing about that. These are the main functions of gNodeB. The main function of UPF we have discussed, right? So this is the main function of UPF, which is packet routing and forwarding. The main function of SMF is the IP address allocation, right? And here I have put the link also, where you can see all the things related to what you call AMF. This is I have seen on some website that all the AMF things you can see here, right? Okay. Then let's talk about a little bit of service-based architecture. So we have already looked at the architecture of the 5G core network and the network functions that make up the core. Now let's look at what is the service-based architecture and how implementing it gives the 5G network all the flexibilities to meet our demand, right? So let's talk about the concept of service-based architecture. So for that, just imagine an online store, right? Just imagine an online store. In the online store, a user can do different things. Like he can do, maybe it can create an account. It can search for products. It can add products to the shopping cart, right? Right? So many things a user can do on the online store. So these features or services are brought together for a complete online shopping experience. The features of 5G network functions can be thought of as a services, and they are invoked by APIs. For example, to page a mobile, a network function called AMF use service APIs, right? So this is the so 5G is the SBA based architecture. So service based architecture provides a modular framework. With SBA, common applications can be deployed using components of various sources and the suppliers. That is why the 3GPP defines a service-based architecture. It is also called SBA. And these interfaces are also called SBI, service-based interfaces, right? And the 5G SBA has many new components like NSSF, like NEF, like NRF. So first function is, you can say, is the NSSF, which is network slice selection function, right? So this function is related to network slicing. So NSSF helps in setting up multiple virtual network slices of the RAN, core, and the transport networks. The main aim is to meet specific service requirements with the help of software, right? So the main function is, first of all, the main function of NS, first of all, it determines AMF set to be used to serve UI, right? And second main function is that it selects the network service network slice instance, right? So these are the two main functions. First of all, it determines AMF set to be used to serve the UI. Second, it selects the set of network slice instance serving the UI, right? Then we have NEF, which is network exposure function. The main function is to do the capability exposure function. It is used by external network entities to interface with the 5G core network. The third one is most important, which is NRF. Which is network repository function. Right? So it aids the 5G service-based architecture. It enables other networks to communicate with each other. So network repository function acts like a directory. So network functions can publish their capabilities. It authorizes access to the network function and facilitates network function discoveries. So NRF is one of the main core components of SBA. Its main function is that it where my screen gone? Just 1 second. The main function is that it register or deregister network function services, right? So these are the main new components in case of 5G. So in SBI, all the communication entities are called network functions. So here in 5G, we're introducing many new concepts. For example, NSSF, NEF, and NRF. So before jumping to some other slides, let's have some small quiz just to have a check. So let's have a small quiz, right? So can you please answer this question? What is a single control plane component that terminates the interface from access networks and from the UE? You can write the answer in the chat box. Yes. So the correct answer is AMF, right? So you can see here that there is a N1 connection between you can see there is N1 connection between AMF and the UE, right? Second question is that which NF allocates the IP address to the UE? Yes, so right answer is SMF. As we have discussed that SMF provides IP address allocation, right? Now let's see. Can you match these terms like UPF, NRF, SMF, and AMF? Okay, nice. Let's see. You can see that NRF, it enables other network functions. Then we have this AMF, which is performs authentication and authorization. And then we have UPF, it is equivalent to user plane of the EPC. And then we have this SMF, which it is the only function for IP. So if you given the right answer, please give a pat on your back, and it means you are following the training. Thanks for giving the right answer. The next question is about NSSF. So can you check which options are the correct one? There may be more than two options. There can be more than one options, right? Okay, yes. So A and C are the correct answers, right? And before jumping to the other concept of 5G architecture, let's talk about my complete 5G course. So here is the course content. So in this course, we'll talk about various things. First chapter will be, or first module will be 5G motivation. So here we'll see why we require 5G, why 4G is not enough. In this, we'll discuss some practical 5G cases. Also, we'll see studies done by various companies and practical aspects of 5G. Then we will discuss about the 5G technical components. As you know that in case of 5G, various components are there. We'll talk about all these documents in details. After that, we'll go through timeline for 5G standards and rollout. In this, we'll talk about when is 5G standardized and how wireless evolves from 1G to 5G. To know the basic features of previous technology is absolute necessity. Only after going through these features, we can relate with 5G, and only then we can establish the motivation behind 5G. So this is the only way to know what are the features required in future, or you can say what are the features missing in the previous technologies. Afterwards, we'll see 5G performance requirements. In this, we'll dissect the requirements which should be fulfilled to call any system as 5G. We'll also explore the gap between 4G and 5G. Or you can say that what are the enhancements in 5G as compared to 4G. Then we'll go through 5G use cases. Here we'll see what are the diverse requirements for each use case. We'll explore what are the steps or things needed to fulfill those requirements. We'll also go through various examples to understand each of these cases in a better way. Thereafter, the topic will be 5G spectrum. As you know that spectrum is the key asset for mobile operators. The available spectrum is a major factor in defining how much capacity and how wide a coverage the mobile network can provide. 5G is the first ever mobile radio system that is designed to utilize any spectrum between, you can say, 400 megahertz and 90 gigahertz. So this is a major plus point for 5G as compared to previous technologies, which has limited spectrum options. So in this part, we'll discuss the different spectrum options for 5G, their characteristics for 5G deployment. After that, we'll analyze the access stream. In this module, we'll use various new concepts related to 5G framework. And then we have 5G deployment options, standalone and non-standalone, that will be discussed in detail. Then 5G architecture, I have just shown you only few nodes in this training, but there are various other nodes in 5G, and we'll discuss in detail in this module. Then we have model tuning. So in 5G, we have vast range of frequency bands. So model tuning is also different. So in this module, we'll discuss model tuning and how to perform model tuning for 5G. So we'll explore all these things in our training. And last chapter will be the network slicing. That will be also discussed in detail in case of this training. So what you will get with this training? So first of all, you will get more than 10 hours of video learning. You can have downloadable summary of each module, right? So if I go to my training, let me go to my training quickly. I will show you what I want to so you can see here. So if I go to training, you can see. So this end-to-end training, it has more than 11.5 hours of training. All those chapters will be there. And you can see we have 350 plus slides, right? And all the bonuses will be provided to you. You can see the testimonials also on this, because many people have gained from this training and gets lots of good jobs and promotion in their company. And in addition to that, this is what I was saying, that so with each chapter, right? With each chapter, you will get just 1 second. With each chapter, you can get lots of books, right? So you can see here, you can go to any chapter, any modules, you can see, first of all, you can get a book, which I referred to complete this chapter. So you can see that this book, and this book is also provided to you. So you can see this complete book. This book will be provided to you. In addition to that, I have made the summary of each chapter, so that if you don't want to go through the video, you can go through this small blog, right? So this you can see here, right? So these are the things. And as I said, books more than $500 will be provided. And then you will get lifetime access and 100% satisfaction granted. Otherwise, there will be refund. But please be honest while returning if you don't like this course, because there is lots of investment in making this course in terms of time, in terms of time, money, making the slides, learning new ways. So it takes lots of effort to put the best material possible. So if you don't like it, please return it. But please be honest. If you don't like, only then you return this course. Okay, and very low cost as compared to other training. If you see that, let me share the screen. So you can see that all these books will be shared with you. So 5G physical layer. So this book costs around $70. Then 5G NR. So all these books I referred to make this course. So all these books will be shared with you, and the combined cost of these books is around $500. Right? All these books will be shared with you guys. Right? And as you know that there are many companies available in the market, but all these courses are very expensive. Right? And these courses are can be go up to maybe for even for 1 hour course they charge maybe $500. So I have done all these courses and I have put the best material possible for you guys, right? And you know that current times are, I have heard I have learned from somewhere that current times are very strange. Companies are struggling to hire people and people are struggling to find jobs because they lack right skills, right? And the cost of this course is around only $49. But yesterday I have completed 500 students, right? And they get lots of good jobs because of this training also. So I want to give one promotion to only first 3 students, that I have reduced the price. I'm going to reduce the price only for first 3 students to only $5, right? So the first 3 students will get only the complete course, 12-hour course for just $5, right? So I'm doing it for just saving it, and you can access this course just for $5, right? If I go to the certification, but that is only for first 3 students, okay? Let me see, is it updated or not? Yeah, so it is updated. So now the price will be $5 only for first 3 students, because I want to say thanks to people that they have complete trust on this course. Okay, so this way you can buy this course, right? So let me go to the slides again and let me go to the summary of what we have read till now. Okay, let's go to this. Okay, so again, with this training, you will get 10 plus hours of video learning. You will get downloadable summary of each module. You will get more than 350 plus slides, right? Let me show you the slides as well quickly. So you will get all these slides with this training, right? So you can see here that we have right now, I've updated some slides. So you can see we have we are around 398 slides in this course, right? You can see here we have more than 398 slides in this course. You will get all the details in this slide, right? So you will get all these slides also with this course. Okay, let's back to our training. So all these things you will get with this course, but for only first 3 students, it will be $5 only for next few minutes. So let's recall 5G architecture. So what we have learned till now. So there are many new technologies enabled by 5G, like the Internet of Things, artificial intelligence, robotics, virtual reality. And these requires a new network approach, both for the access network and for the next generation core. The 5G system is more than just a radio access technology, right? The 5G has defined the functional architecture, or you can say service-based architecture, right? So in 5G implementation, technologies can evolve and be replaced over time. So implementation is not fixed, unlike previous technologies. In previous technologies like LTE, 3G, once network is deployed, then you can't change much in it, right? Then we have gone through LTE network architecture. So here we have reviewed the main nodes in LTE. So if you are LTE operator today, you are end-to-end operator, where you have got your own radio access network and your own EPC. So you will not directly jump to 5G standalone, but first you will work in the non-standalone mode. Then we have seen the evolution of mobile RAN, right? So prior to 4G LTE, the RAN transport consists of two segments. One is front haul and one is back haul. The front haul typically coaxial cable connected the remote radio head mounted near the mobile antenna to the baseband unit at the base of the tower. The backhaul usually is a microwave link or a fiber connected to the BBU to the mobile core network. But as the industry migrated to 4G networks to meet the higher bandwidth demand and to cater the increasing mobile subscribers, okay, people are asking for the link. Sorry, let me give you the link of the training. Just 1 second. I forget to give you the link. Give you the link. So this is the link to the training. Okay, let me go back to the training. Okay, so the backhaul usually a microwave link or fiber connected to the BBU to the mobile core network. As the industry migrated to 5G networks to meet the higher bandwidth and to cater the increasing mobile subscribers, there was too much pressure on the mobile base station. The traditional role of base station has been divided into two functions. One is radio unit. One is the radio unit and the other one is the centralized unit, or you can say the BBU. The central unit was moved up to maybe 20 kilometers away from the base and could process traffic from multiple towers. The distance and the bandwidth involved require optical fiber front haul to connect to RU to the CU. Requirements for 5G have become even more complex and need a brand new approach to the RAN. The 3GPP has introduced new interface and modules for 5G. So in addition to RU and CU, a distributed unit and other modules and concepts are introduced in 5G. So in 5G, is likely to be near the sites, right? And then we have discussed the various differences between LTE and the 5G. And also we have discussed 5G architecture and various network functions, right? So in summary, you can see here that ngRAN is connected and it's made up of various gNodeB, and multi-rat connectivity is supported by gNodeB and eNodeB connected to the 5G or 4G EPC, right? And gNodeB implemented using CU and DU, and their various functions RLC can be deployed as a virtualized network, right? So this is all about 5G core. Again, friends, thanks a lot for joining this webinar. Please invest in your career, and I'm fully confident that this is the best and the complete 5G course for you. And around 500 people have taken benefit from this course. And I hope if you join this course, you will be also be benefited, and it will help to get a new job in 5G, or it will help you to get promotion in your course, right? So again, friends, thanks a lot for joining this training, because I feel winning or success is only combination of your passion, your skills, your experience, and target. And skills, this part can be covered with the help of this training. And if you do this training, and then nobody can stop from winning, right? And moreover, there is a return policy is there, so you can return this course anytime within 6 months if you do not like it. So you are on the like win-win side only. Okay. So again, friends, thanks a lot for joining this training, and enjoy your rest of your days. Thanks a lot, guys, for joining this training. Yes, so you can use only the PayPal to buy this training, and you don't have to do anything problem. Like you just have to give your credit card. Just put your email address, and let me show you what I'm talking about. So let me go to that quickly. So if I go to maybe this thing, and you can see here, and if I sign in or maybe get started now, so you put any email address like this, and put any name, and if you go to just click on this pay with PayPal, and then you just have to do this pay with debit or credit card, and you do not need any PayPal account, right? So just pay with debit or credit card, and you are good to go, right? So just give your credit card and everything will be set. Okay. So have I given? So Swapnil, is it working now? Can you check it? Okay. Okay, so 2 people already bought the course, so only 1 slot is left for $5. Okay, so let me check. And so I will not stop this offer for next 1 hour. So let me check where is the problem, and you can check after like 30 minutes. Okay. Okay, friends, thanks a lot for joining this training, and see you maybe next time. Okay, thank you. Bye.